again, we're back here in the Space Vehicle Mock-Up Facility in Building 9, and this time we are over in the Argos area with the Argos Project Manager, Larry Duncan. Thanks for coming and talking with us, Larry.
Thanks for coming over.
So Argos, it's an acronym. What does that stand for?
It's the Active Response Gravity Offload System. So what we basically do is we make you feel like you're on the moon, Mars, or microgravity with a full robotic system. So this whole entire large structure is a large motion-based platform. And so what we're doing, we have a crew member in the system today. He is in microgravity doing an asteroid simulation. And we have him in microgravity, so we're offloading 100% of his weight.
So he feels basically like he's in space then, right?
Basically like he is in space.
Wow, so, and we use that to simulate spacewalks?
Spacewalks, we can do crew training, we can do equipment testing, we can actually do what's called mass handling, where we can float an object and have people feel like it's to move a large item around in space. We've done robotic legs.
Very cool. So, and what are we using it for desert rats?
It is being used for EVAs, simulations, so what they're doing, spacewalks. So yesterday they came out of the cabin and did a spacewalk in Argos, and then we go back into the cabin. We're doing the same thing tomorrow. So
the cabin is the space exploration vehicle. That's kind of their home away from home for short 1 or 2 week excursions. But they're going to want to get out of the vehicle and actually do some hands-on work with the surface of the asteroid, and that's where the spacewalks come in.
That's correct. And today we're doing a standalone simulation that's actually comparing Argos to the NEMO simulation that was done earlier this summer down in Key Largo, Florida.
NEMO is, of course, our underwater analog. RATS is our one analog, and NEMO is another one, go underwater to simulate a mission to an asteroid.
So one of the things we're looking at is each analog has its own pros and cons, and so we're doing a comparison of the two of them with the simulation today. So what he's doing right now is coming down a boom that he would have deployed off of a vehicle, and is coming down and preparing to take a core sample or deploy a geological or geophysical instrument.
Very cool. So this, tell us a little bit about booms. Why, one of the things about asteroids is that they're hard to move around on. What is that about?
In microgravity, it's very hard to move around because you don't have any ground reaction force. If you push off something, you will float away. So the boom gives you a work surface. On space station, they have handrails and tether points, and all that was built before the ISS was launched.
Built for people to use, specifically for that reason. Asteroids, not so much.
Asteroids are going to be a little bit more challenging. So the idea is with the boom is you can come off the back of the vehicle, deploy, say, a large robotic arm or a boom, and then you can go out and use that to work off of, kind of like a workbench or a work platform.
And you can kind of just, like he was doing, move it hand over hand, along the boom to get to different areas that he might be interested in.
That's correct.
Okay, and then what do you do once you get to where you want to go?
Like what he's getting ready to do here is deploy a simulated geological instrument that you would leave behind on the asteroid to take future readings, similar like what we've left on the moon.
Okay.
When we went there.
All right, and that's one of the many things that y'all are simulating during these spacewalks. What are some of the other ones?
We're simulating doing sample collections of rocks. How do you pick up rocks? How do you pick up all different types of rocks? We're not really sure what an asteroid is. It can be gravel, it can be large pieces of rock, be like sand-like. So what they do is they come in and take different samples of picking up the rock, taking like a core sample in sand where you may be wanting to get a piece from a couple feet under the ground. And then also if you've got a really big rock that's really interesting, how do you break a chip off of that and bring it home? It's a whole lot harder than just taking and hitting a rock on the Earth.
We don't have enough room to bring the big rocks with us.
That's right.
And I think you've got some stuff to show us with ways we could do that.
So this here is some of the rocks that we take samples with. We've done simulations on this where they have to come in with the bag and pick them up. And it's the Apollo astronauts had several thousand hours of geology training before they ever went to the moon. There'd be this similar training if they went to an asteroid. And they'd be taught how to pick up rocks, how not to contaminate them.
Okay.
One of the real challenges of an asteroid versus the moon is how do you take a rock sample of something that will float away? So another group has developed a bag that is literally, the idea is it's got wire in it to stiffen it, and you would wrap this around a rock, and then you could come in and do hammer chipping and chip a piece off and have that rock chip contained inside of this area. And then you could take it away and then collect your sample.
Otherwise, you start banging at the rocks, they fly to pieces, and you've lost them, right?
It's going to go all over.
Okay. So there's lots of different things we need to learn before we go to an asteroid.
That's correct.
And RATS is a great way to get started on some of those lessons we need to learn.
Right. And some of it is you're building early prototype tools. You can test out the tools, see if they need improvement. You know, you really have to design, build, and test something to understand it.
And then I guess with Argos in particular, it's more, do we have this stuff we need to simulate an asteroid spacewalk
Right.
before we send people out to go do one?
That's correct.
And so far, so good?
So far, so good. This is our second generation system. We actually started the project about 5 years ago. Our generation 1 system worked very well, but we came in and made a lot of improvements. The system we have here we brought online right after Christmas, and it's been used very heavily since then.
Very heavily. I think we've been here a few times now. So thank you so much, Larry, for coming and talking with us. Again, Larry Duncan, who is the project manager for the Argos system, and here today being used for the RATS simulation of an asteroid mission.